here that we need to figure out. Even though it's not a part of an angle, it's of a triangle, it's a part of a straight angle. If this is 90 and this is 10, 90 plus 10 is 100, so therefore this is also 80 degrees. And now we have our chute filled in. And now that we have our chute filled in, we can go ahead and we can do A, B, C, D, and E. Alright, so A, B, C, D, and E, once we look at our chute, we can figure out that those are... Now, I did find a mistake. Once I got to E, I realized, and I looked over and I was double checking, this angle right here, I told you it was 100 degrees. It is not 100 degrees, it's 90 degrees. Because if this is 90, then that means the sum of these two angles should be 90 as well, because 90 plus 90 is 180. And if this is 10 degrees, then that means this has to be 80 degrees. So that angle right there is 80 degrees. Okay? All right. So basically, if you know the two angles in a triangle, you should be able to figure out the third angle. If you know one angle in a supplementary angle, you should be able to figure out the other angle. Let's move on. Now that you have your chute filled out in number 5, you should be able to do number 6 and number 7. So pause the video at this time and do number 6 and number 7. Welcome back. Once you have this filled in, you should notice that all three angles in a triangle, no matter what, when you add them up, they add up to 180 degrees. 180 degrees. Let's move on. Number 8. In diagram, WT is parallel to PQ. So we're looking at WT. So we're looking at this line is parallel to PQ, which is this line. So those two lines are parallel to each other. A says, use what you know about parallel lines and transversals to determine the measure of angle RPQ and angle RQP. Now notice that this figure has two different transversals. We have one here and we have another one here. So it has two transversals in this figure. It says we're going to find the measure of angle RPQ. So I'm going to go ahead and follow RPQ. So RPQ. So we are looking at this angle right here. We're looking at that angle right there. And then we're going to figure out RQP. So RQP, we're going in the opposite direction, so we're going to figure out this angle right here. So we're going to figure out both of those angles. I want you to pause the video and then try to figure that out. But go ahead and answer the other questions as well. Do B, and then in number 9, you can see here that they gave you 2 angles. Try to find the missing angle over here, and then come on back. Welcome back. So for this figure right here, we're going to figure out that the measure of angle RPQ is 70 degrees and the measure of angle RQP is equal to 80 degrees. And for some of you, you may have figured it out, and for some of you may be struggling a little bit. And here is how I did it. Number 1, I looked at the figure, and this is a straight angle. If this is a straight angle, and I know this angle, and I know this angle, I can subtract them both from 180 degrees. So 180 degrees minus the addition of 70 plus 80 degrees is going to give me back 30 degrees. So this angle right here in the middle of both of these is 30 degrees, and you can't really see it when I write it in there, but 30 degrees. Okay, so that's how I found that angle. Now, once I knew that angle, I know that all three angles in that triangle PRQ is going to add up to 180 degrees. However, I only really know one angle in this triangle, which is the 30 degrees. So I still need something else to figure out the other two angles. Now, what did I do? What did I do is this, and I need you to pay very close attention. Yesterday we learned about different types of angle: corresponding angle, alternate interior, same side interior, all of that good stuff. So what I want you to notice about this shape is this. Let's get everything out of the way. We have two parallel lines. We have this line and we have this line. I want you to pretend that there's only one transversal here. There's only one transversal. Let me get a different highlighter color here. And we're looking at this transversal right here. If we're looking at this transversal right here, and we use the alternate interior angles, this is an interior angle, and this is also an interior angle. And what do we know about alternate interior angles? They are congruent. So if they are congruent, then that means that this angle here is also 70 degrees. And that's how we know that that angle RPQ, is 70 degrees. Now, with that being said, let's take a look at something else. I'm going to erase this. If we look at our parallel lines again, and we're looking at, let me get a different shade, this transversal here, right? We know using alternate interior angles, this and this are both alternate interior angles. So if this is 80 degrees, then this is also 80 degrees. And that's how I know that those are 70 and 80 degrees. So you have to, in your mind, picture one transversal cutting the two parallel lines in order to figure that out. The other thing that I want to tell you is this. If we know all three of these angles, and this is a theorem, when we come back we're going to do an activity to prove this. If we know all three of these angles are 70, 30, and 80, we automatically know that this angle is 70 degrees and this angle is 80 degrees. Because if this is angle A, angle B, and angle C, this is also angle A, angle B, and angle C. And we will prove that when I come back on Monday. Okay? But in the meantime, you should recognize that the transversals cut two parallel lines. For number 9, fairly simple. We know all three angles add up to 180. We subtract 90 plus 48 from it, and we're going to get 42 degrees. The other thing that you should know is this is a right triangle. So if we know that this is 90 degrees, then we know that these two angles add up to 90 degrees. Therefore, 48 from 90 minus 48 is going to also give us 42 degrees. So there are different ways to find these angles. Let's move on. Chip has discovered an error in programming of a game. Before a triangle appeared, a player selects an angle with a measure of 100 degrees. And the computer selected 82 degrees for a different angle measure. Explain how Chip knew there was an error. So we're looking at a triangle here, right? So for me, I'm very picturesque. If I'm looking at a triangle, it says, Chip discovered an error in programming game. Before a triangle appeared, the player selected an angle with a measure of 100 degrees. So one of these angles is 100 degrees. So let's say this angle is 100 degrees. If this angle is 100 degrees and the computer selected another angle, and let's say this one is 82 degrees, yes, there's an error, and you should be able to figure that out. So I'm going to pause here for 5 seconds, and let's see if you and I are thinking the same thing. All three angles in a triangle add up to 180 degrees. Right now, we don't know what this angle is, but the other two add up to 182 degrees. So that's impossible. So this is an error. Somebody here is wrong and it needs to be fixed. Okay, so that's what the error is. You can't have angles in a triangle being more than 182 degrees when they all add up to 180 degrees. Let's take a look at number 11. The measure of three angles in a triangle are x, 2x plus 4, and 2x minus 9. Write an equation on the relationship between the three angle measures and then solve for x. So, we know that all three angles in a triangle add up to 180 degrees. So we just need to add them up and set them equal to 180 degrees. So we have x degrees plus 2x plus 4 degrees plus 2x minus 9 degrees equal 180 degrees. The next thing I'm going to do is I'm just going to remove the parentheses. X plus 2x plus 4 plus 2x minus 9 is equal to 180 degrees and solve for x. At this point, you should know how to combine like terms. So I want you to go ahead and combine like terms. And when you combine the like terms, go ahead and solve for x. And once you solve for x, come on back. So pause the video at this time and then come on back. Alright, welcome back. So you can see here that when you add all three up and you combine like terms, you should have gotten 5x minus 5 is equal to 180 degrees. And when you solve down for x, you should have gotten x equals 37. Once you got x equals 37, you go back to your original equations and you substitute for x. So your first angle is 37 degrees because when you substitute 37 for x, it's 37 degrees. When you substitute x in your second angle, you're going to get 65 degrees. And when you substitute x in your third angle, you're going to get 78 degrees. And the last thing Miss Smith always does, I always check to make sure that my answers are correct. So I added all three of them together. And because they equal 180 degrees, I know that I am correct. Let's move on. So today we took a look at angles of a triangle, angles in a triangle. When you walk away from this, you should know that the angles in a triangle, when added together, all three angles equal 180 degrees. You should be able to write and solve equations involving angles in a triangle. See you in lesson 17-2. If you want to, and you're still confused about something, go back and look at the different parts of the video to make sure you have a good understanding of the lesson. See you in the next lesson.